Okay. All right, everybody. Welcome to Homeport. So today we're going to see some more demonstrations. We're going to have a demonstration from Matternet and their collaboration with Labo Berlin. Before we get there, and actually just a reminder, this is going to be live streamed on YouTube and into the Congress Center. So before we jump to Matternet, we're going to have a brief introduction from Dronig. So Jan-Erik Putzer. Dronig is a traffic management solution that is supporting the demonstrations here in Homeport. And he's going to tell us a bit more about their solution and how it's supporting the operations here.
Yeah, thank you, Luis. And a very warm welcome from my side to the ETS World Congress 2021 in Hamburg. And I imagine some of you have come today with a car to the Homeport, and I thought traffic signs, road signs, markings on the street, and you have to follow certain rules when you use the car. But what about the sky? It's blue, it's cloudy, it's actually really nice, you don't see anything, no traffic, nothing. But do we have rules up there? Yes, certainly we do. So over the past 60 years, we have been established rules to ensure safe and efficient air traffic by using air traffic management systems to visualize air traffic. And exactly here lies the challenge for us. Drones are currently simply invisible for manned aviation because the radar coverage simply doesn't go as low as drones currently fly. So we have to make drones visible, and the very important thing is to display them together on one display with the manned aviation to ensure safe operation in the sky. So what is a drone now? The drone is no longer a toy. It has become a tool. It fulfills special needs for pipelines inspections, for instance, or medical transport, just to name a few. And all these operations will take place beyond the visual line of sight. That means that the drone pilot, has no visual contact to the drone. And that's why we have to display the drone to the pilot and, of course, to other people in the air. And the other thing is it a good thing just to buy a drone and to unpack it, to load the batteries and to go fly? No, I don't think so, because you have to know some rules, some aspects of legislation to do and operate your drone safely. For example, maybe you have to have a certain training to operate your drone. You have to have a risk assessment to fulfill, or you even have to write ConOps, how you operate your drone. Everything is not easy, but it is possible. And to be honest, to solve these problems and to give answers to these questions, Dronig was founded in 2019 as a subsidiary of DFS Deutsche Flugsicherung and Deutsche Telekom. Our main focus is to safely integrate drones into the existing aviation environment. So we support our clients in all phases of the mission, prior, in-flight, and even post-flights. And the major topic, as I said, we have to make the drones visible. And we do that by using mobile technology and transmit the position of the drone in air traffic management systems, just like DFS. And so we combine manned and unmanned aviation and one display, and this is how we ensure a safe integration and the operation in the air. So Dronig fills the blind spot of air traffic management in the very low airspace, as we call it, by using our own infrastructure. That means we have antennas. I think around Hamburg we have 5 different stations. One is on the Heinrich-Herz-Turm and 4 around the areas to ensure that we see drones when they use our technology. In addition, I think I have it here, we have the so-called small hook-on devices, so mobile devices. They transmit their position via the mobile network communication system into the DFS air traffic management system. And by doing that, we really have the possibility to combine these two, so the manned and unmanned traffic. And this sort also receives data of other air traffic around when the drone is in the air. So we're using ADS-B and FLARM. These are standard functions already existing in the aviation environment. Okay, so what do we see now? We will see the display. On the table, you find these cards. There are some QR codes. You just picture that, and then you can follow the complete operation of Matternet, which they are doing. You can also, I think, look at the screen, and so you can see what the drone is really doing. And even if we find other aircrafts or other traffic around, you also see them. So that gives the pilot of Matternet, the operation, the possibility to really avoid other traffic. And not to have any accidents. And that's actually why we're here for. We're here for to ensure safe operations on the home port at the ETS 2021. So thank you very much for your attention. And now back to Luis.
Thanks, Jan-Erik. So, as mentioned, we're going to hand over now to Matternet and Labo Berlin. We have Klaus Tenning from Labo Berlin and Alex Norman from Matternet. They're going to talk us through a project they've been doing around sample transport. And then after that, we're going to actually see the live demonstration. And then there'll be a chance for some questions from the audience, if you have any, and we'll go from there. So without further ado, handing over to Klaus.
Thank you, Louis. And I'm very excited to be here and present you our drone shuttle, Labo Berlin and Matternet. Just to give you a short introduction, who is actually Labo Berlin? We are Europe's biggest hospital lab for lab diagnostics, sitting in Berlin. We are serving all the hospitals of Charité and Vivantes. That's 13 sites in Berlin. Just give you some facts and figures. So overall, we process 30,000 samples per day. And of course, those samples have to somehow be transported to our central lab. With that, we're driving actually 400,000 kilometers per year by car to transport those specimens to our central lab. We as Labo Berlin, we always strive for innovative solutions in order to improve patient care. And this is a very special project where we have the goal to drastically reduce the time from a patient taking blood to result. So what's the use case of that? We have several emergency departments all across Berlin. And to give you an example, if somebody comes to the emergency department of the campus Benjamin Franklin, that's in the south of Berlin, and he or she comes with unclear pain, stomach pain, chest pain, and an overall bad situation of the patient, it could be that there is an intoxication of the patient. So what we have to do, or the medical doctor has to do, is to get a specialized toxicology diagnostics as soon as possible. That's a very special diagnostics. This can only be done in the central lab. Our central lab is at the Campus Virchow-Klinikum, that's in the west of Berlin. So we have to get the sample as soon as possible to our central lab. Currently, that's done by a courier that comes extra for that sample, but still it takes in the traffic of Berlin almost 60 to 75 minutes to get this sample to our central lab. So what we want to achieve to drastically reduce that time from now 75 minutes to 10 to 15 minutes using intelligent drones together with our partner Matternet. From the beginning on, we decided that we don't want to have a kind of proof of concept and just show, okay, that's technically possible to realize such a solution, but we want to start as soon as possible really a routine logistics solution all across over Berlin in order to have a direct connection for all these emergency settings from all our hospitals to the central lab in Berlin. So we said, okay, this is only possible if we select the right partners, and we were quite lucky that we got a lot of interest by also all the federal ministries in order to really realize such a project as soon as possible, and I hope this will be very soon. And that's also why we choose Matternet as our partner, because we still see that they are technically the most have the better solution currently available, and also have already operations in the world, in Switzerland and in the US, but I guess Alex will elaborate more on that. So we are happy to show you a little insight today, as well as the live demo. And now I would hand over to Alex to explain you the technical details of the solution.
Thank you, Klaus, and also from me, welcome here to the home port in Hamburg. So now to overcome these challenges that someone like Labor Berlin faces in nowadays logistics, Matternet has focused on really solving this issue, not just for the developed countries, but also in developing countries. And so also from this concept, essentially, stems our name, Matternet. We envision that there will be something like the network of information today, like the internet. Maybe in the future there will be something that's the network of matter, so a new layer of logistics across a city, for example. So with that, we envision a network of drones operating in a city, and this network will be predictable, first and foremost, so we will know exactly the distance and the time that we'll need from one location to another, especially in a use case like the one from Labor Berlin. This is something very valuable. As well as, obviously, the speed and the cost efficiency will play a big role in this small, urgent logistics. So Matternet is actually around since 2014 as really in operation, and we started in developing countries doing some missions in Malawi, also Papua New Guinea, to really support the population there and enable them a better healthcare. But very soon we pivoted more to the developed countries, and we set up the first, world's first BB loss operation in the country of Switzerland, in the south of Switzerland, to be more precise, in the city of Lugano. So we flew over the city of Lugano beyond visual line of sight back in 2017. We then set up the first commercial operations in Zurich, and soon thereafter also in the US, where we are currently undergoing the type certification process with the Federal Aviation Authority, and are hoping to obtain soon this certification to also enable a larger scale operation in the US and also across the globe. So our technology is not just a drone, or many people might think first about the drone because that's what you see, but there is a lot that needs to come together behind the scenes to actually work for a safe operation over a city. So we actually have four main pillars in our technology. So one is the platform, so the software systems that we develop in-house. Then we have the drone itself. As an additional piece, we have the station, so we call it the Matternet station, which is essentially the node of the network. So if you think about it, so we want to enable this asynchronous network. So for this, we need a receptacle station, essentially. And then the last, but definitely not least piece here is the mission control center that we developed that allows us the safe integration of drones into the already used airspace. And so all of this works together basically in this architecture to allow the safe operation. Here also we see again how, for example, we integrate also with Tronic, in this particular case here, through the software system or the cloud system. We actually integrate with Tronic and share our position, and in turn also we will get position data of other aircraft in the area, and so we can enable a safe operation. Maybe the interesting thing here is also that we are not having attached an additional device to the drone, but our drone is automatically connected to that system through the back end, essentially, as part of basically using the first use-based services available. Essentially, then if we look a little bit closer at the drone itself, and you will see it flying later today, the drone itself has a range of around 20 kilometers at a speed of around 70 kilometers per hour, and has the ability to land precisely on a 1 meter by 1 meter platform that you see sitting outside there. We also have a parachute system installed that would deploy in case there's something out of the ordinary or we need to deploy the emergency system. Additionally, we carry also devices that allow other aircraft to detect our aircraft, such as, for example, FLARM. With that, we can also alert other helicopters that we are in the area, as well as they alert us through that same system. So mission control, and actually we have set up a mission control center down below to now oversee this operation. Is enabling us to have multiple drones in the air at the same time, and we managed to integrate in the UTM, so the Unmanned Traffic Management System, in a given area. So we can integrate with different USSPs or service providers in the different areas. And that allows us this traffic awareness and really enable the safe operation in an already used airspace. So where do we already have operations across the globe? So Lugano, we have around more than 5,000 flights over the city of Lugano. Zurich, a little bit more than 1,000. North Carolina, around 7,000 flights with UPS, as well as Kentucky, a little bit more than 1,000, and Florida, more than 2,000. So these are all commercial flights that are happening as we speak every single day and connecting hospitals and laboratories. In Florida, we are transporting prescription medicine as part of a COVID relief operation where we help retirement communities. And all in all, now if we also take all our test flights into consideration, we have around 38,000 flights on this drone that you can see here today, or this model of the drone, which really gives us the, I would say, the edge here and the understanding of our system and development. So here you see a picture of Lugano, where we fly also every single day and support the hospital in this area. In the US, an interesting piece to know also is that we are operating together with UPS. And UPS is operating under Part 135, which is essentially an airline certification. So they are able to fly this drone under a normal airline certification. So this is something that is quite new in this area. And they're able, with this special exemption, to operate the Matternet M2 under their Part 135 certification. So this shows also a little bit what is necessary to even just operate this particular drone. And in Switzerland, we have set up our own, so to speak, airline, which follows basically also the manned aviation regulatory aspects, and everything from training programs to manuals needs to be in place to be able to operate this system. So we are far away from really a toy here. It's more of an airline operation, essentially. And so now I want to show you a brief video of what this station will look like in the future. Or actually right now, because we just installed it in the city of Lugano, outside of the hospital. So you see someone can just access the station with the right authentication and can place a box in the station. The station will then automatically load the payload box into the drone. All the pre-flight checks will be conducted by the station and connected with the mission control. the station opens, and then the drone will fly out of that station and automatically follow the predefined path to its destination and then land on the other side to deliver the package. So here you see a picture actually of the station as it is right now sitting in Lugano. This is a photo of the courtyard of the hospital taken last week with the drone landing on the station. So this is really the last piece of enabling this network and really get to this fully asynchronous network that allows us to receive and deliver goods through that aerial network. And beyond that, this station also allows, for example, charging batteries, so we can automatically swap batteries and then enable this fully integrated network into a city. So with that, essentially, we're also trying to enable such a network, or that's at least our vision, in the city of Berlin. And I will show you now, also, you will see in a couple of minutes how this could look like with a real flight out there. We will do a small round around the channel and then come back and land. So my team is now getting ready and preparing the drone for takeoff. While the team is doing that, I'll show you a video of what the process could look like. Essentially, you could have any hospital in the city of Berlin. In this case, it's, for example, the Charité Benjamin Franklin Hospital. These hospital has an emergency laboratory, but maybe in the future that's not even necessary anymore. Here you see they scan the box, so there's a full chain of custody. In this particular case, we also had another hospital that is preparing a payload, scanning the box, creating the manifest, essentially, that's handled through our system. And automatically then the network is basically aware that this is happening. And the personnel can then bring the box either to the station or outside to the drone pad, what you can also see here today. So if you turn around now, you will see the drone then take off in a couple of minutes and basically deliver that payload box to its destination. So there's a couple of checks that need to happen at this point. Mission control is essentially checking that the airspace is clear and all the systems on the aircraft are a go, essentially. And once that is the case, the aircraft will take off and proceed through its pre-designated path, essentially, fully automatic. There is no pilot essentially commanding the drone by a stick. This is fully pre-programmed and the drone will just follow its path, essentially. In the different areas where we operate, this operating procedure looks slightly different depending on the regulatory environment as well that we need to follow. We have the specific checklists that we need to follow. And also the drone itself is constantly checking essentially if all its systems are good and making sure that the drone actually is self-aware of its state and making sure that essentially it's taking off only if every safety check is passed. We're also coordinating here with the different authorities, in this particular case also for the channel. So if there's any ships or anything, we currently are waiting for these to pass for this demo particularly. So you see now the drone is armed and is about to take off and proceed to its destination. So we are, for this particular demo, we are flying in about 30 meters above ground, and this fully automated path essentially along this river or this channel, and then come back and land and deliver the payload. Again, this is a fully automated flight, so there's no one really controlling it as you might be used to from smaller drones, and will essentially only alerts in case there's any problem or something that needs the attention of the person that we call the flight director, which is sitting in front of mission control and ensuring that this is a safe flight. You will see now the drone approaching the landing area. At this point, it will actually ask our cloud system if it is allowed to land, because in the future we will have multiple drones actually trying to land potentially at the same location. Or also we have the station that needs to open the petals, for example, so that it allows the drone to land. So once the station has given the approval to land, the drone will proceed to the landing pad and then land exactly on this 1 meter by 1 meter landing pad. So in order to enable this precision landing, essentially we have developed a system that is installed into the drone and also the landing pad in order to enable this precision landing that also allows us to land, for example, close to buildings or in more GPS-denied environments. Yeah, now the box could be taken from the drone and then delivered to where it needs to be delivered. And that's essentially also everything from my side for now. If there are any questions, also I will be around, and I'm happy to answer any question. I think maybe, yeah, we are open to a little discussion here now.
Great. Thank you, Alex. It was great to see the drone actually in action. So, as we said, we're going to ask the audience if there's any questions immediately now. Otherwise, I have some questions listed down. So, does anybody have any questions right now? Sure.
Sure. Hi. Thank you. I actually have a question for you, Klaus. What kind of evidence are you looking to generate on the benefits of this technology, the cost and the cost effectiveness for your organization to make decisions about potentially scaling the drone service?
Thank you for the question. So first of all, and that's what we said, we want to focus on these emergency specialized diagnostics. To give you an idea, it's around 600 to 700 of those diagnostics per month. So that's a lot, but nothing compared to the 13,000 per day for the regular diagnostics. And for that, of course, the new solution, also delivery by drone, has to compete to the standard solution that we currently have. But we definitely see a huge benefit for the patient itself, as well as the medical doctor, who really has to decide what treatment to start with. And there's then also the question how to measure the benefit of a patient. For that, it's really time, and there, when we say we can save like 1 hour, there really the time equals life, maybe, actually. So that's definitely something worth to invest in. And then, of course, when we want to scale for also the routine diagnostics, transport, then of course it has to compete with the current logistics solutions that we currently have.
And maybe just a quick follow-on question to that, which is probably more for Alex. So obviously, when we're dealing with diagnostics and samples, the payload is quite small, and your model is based on having many, many drones flying at once. Do you foresee in the future larger payload or bigger drones, or is it just a case of scaling more and more drones?
Yeah, so we are also developing larger drones to really address that need. However, there is a certain sweet spot somewhere in this size of drones. We don't envision this to go much beyond that, and rather focus on the urgent deliveries and really focus also on these specific use cases.
Okay, thank you. Are there other questions from the audience right now? If not, I'll jump on to my next one. So this was about the regulatory aspects, and obviously the payload would have a play on that and what you have to go through. Can you maybe talk us through some of the issues or the hoops that you've had to jump through and how you've dealt with them?
Yeah, so we as Matternet, we are operating now in different jurisdictions essentially. So we are working with the FAA in the US and with the Swiss authorities in Switzerland and EASA as well now, especially for anything that's happening in Europe. So everyone has its own kind of approach to this, which alone already makes it a little bit difficult. Especially when we talk about certification of drones or really the specification that goes with this certification, apparently that should be at some point. And so, for example, in the US, we are following this type certification process, which is a very strict process. But at the same time, the FAA is, as we go, trying to figure out what the rules should be. And that's obviously challenging also as we develop our drone, because as these things just evolve, it makes it difficult. And similarly with the EASA, just recently they were publishing some of these rules, and countries are trying to implement them, but the challenge here is countries are not ready for this yet. And so we are facing this challenge together with them, and also we're trying to work through that with the regulators and really try to establish a good relationship that we can enable drone operations on a larger scale in the future.
Great. And another question, so when you, as you mentioned briefly in your presentation, when you started operating, a number of your operations were in the Global South. The operations that you seem to be running now are more in the north. Is there a plan to go back to the Global South, or is it more focusing in Europe and the States for now?
Yeah, so our vision definitely is to develop a solution that can work out of the box, essentially. So we send drone stations to a location, and you can install it, and basically you have a new layer of transportation. And in order to develop that, we decided to also move a little bit more to the north to be able to also scale and work on this solution until we have it ready and be able to deploy it also at a lower cost in these areas to deploy it easily.
Okay, are there any other questions from the audience? Yeah? Okay, I'll hand over here.
Hi, thanks for the presentation so far. My question for you is, what's your elevator pitch to someone in the general public? They're asking you, why are you flying drones? What do you tell them?
So basically we are flying drones to get people access to goods as frictionless access to information. Yeah.
Okay, short and sweet.
And maybe I can also answer that for the specific project. There I would say quite similar to currently when you have let's say a car accident somewhere. You have to decide, do you actually drive with a normal medical car there, or do you think it's a severe injury, so you have to send the helicopter there? And that's kind of similar to what we think our project is. When we have an emergency setting, we want to use the drone to transport this human sample as soon as possible to the central lab. If it's kind of a routine diagnostic, where if the result is there in 1 hour or 2 hours, it doesn't matter, then we can, of course, also use the current state of logistics that we currently already have.
Yeah, we got another question from the audience.
Thank you. So far you started with use cases in the health sector. Are you thinking about going beyond health sector as you are scaling up both from the geographic standpoint, but also the type of product you can transport?
Thank you. Yeah, so our focus definitely is on the healthcare, and the reason for this is mainly for now, obviously, the fact that these are usually small, urgent deliveries that are urgently needed, as well as we know the point A and point B usually, which makes it also a little bit easier right now in the regulatory space. We are not close to any opportunities overall for e-commerce or food delivery, but in the end also it needs to make sense. It needs to make sense both economically, but also a little bit on basically the common sense side. And yeah, and I think once the technology and also the regulation is ready for it, I think we would be open to explore and see what possibilities are out there. But the focus is now clearly on healthcare and also distribution of medical goods.
Maybe linked to that question, is there or are there any specific considerations that need to be taken into account when transporting biohazardous material or blood samples, these kind of things, and maybe how you dealt with those?
Yes, so there's standards. So we are following from UN stands for transporting medical goods, essentially. And depending on what goods, it could also be classified as hazmat, so hazardous material. And in this particular case, we would go into more detail on what is required in terms of making this safe. And there's standards out there already for aerial transport, but also road transport that can be used for that. And we are applying also for our current operations in Switzerland.
Okay, so with that in mind, in a worst-case scenario where maybe you lose contact with a drone, it starts flying towards an urban center, what happens and how do you deal with that? What is the contingency plan?
Yeah, so the drone itself, as mentioned before, is equipped with a parachute system. The payload box itself is secured inside the drone. Essentially, you see that it's locked below with 4 bolts. And so no one can access the payload unless he has the necessary authorization. And with that, essentially, the drone would automatically deploy the parachute and come down on the parachute and keep the drone secured inside the payload, secured inside the drone, and would only give access to the people that are allowed to. And we have emergency response plans in place that we would deploy our action once something like this would happen.
What if it came down over water?
Over water, right now, basically that would mean the drone would probably float for some time, but then would submerge.
Great. Are there other questions from the audience? Yeah.
It sounds amazing, all of the flights you've already had. What has it meant for noise complaints? Any concerns? Anybody calling police and freaking out that there's a drone flying over them?
Yeah, thank you. So public acceptance in general obviously is a very important topic that we also focus a lot on as we fly in densely populated areas. And we have received the one or other noise complaint, but it wasn't something that couldn't be addressed, essentially. And also, you heard it today. I mean, the drone is not very loud, and as soon as it is in the air, essentially, it starts to disappear. So it's actually not so much the noise, but it's rather the feeling that something is flying above your head, which is weird to people. And so I think it's something that we also start to need to get used to and just try to experience more and more, and people will start to accept it, I think. And also to understand a little bit better the technology behind it and how things work, I think could help. So what we did also in Zurich and Lugano, for example, is campaigns for public awareness and give the possibility to also ask questions, how things work, and yeah, enable people to get closer to that new technology.
Is it also easier to run a drone operation from a hospital which is launching a helicopter regularly, or in terms of the noise?
Yeah, oh, absolutely. But it is interesting, you know, people are used to a helicopter and know the helicopter and know the sound of a helicopter. And so it's different. Yeah.
Cool. So another question, in this case on the platform, the launch station, if you like. I know there's other sort of manufacturers working on logistics sort of launch stations. Would there be a plan to integrate the Matternet drone or make it able to land on kind of maybe technology agnostic station, if you like, or is it always going to be linked specifically to the Matternet ones?
I guess I would answer this a little bit egoistically in a way that maybe it would be the other way around, that maybe we would have stations of Matternet that can be used by other drone platforms. Integration is not that easy. So basically to make something work really seamlessly from the end to end is not that easy. And so that's why we decided to really build the end-to-end solution and not just one piece of it. And I think that would be the main challenge, to start to integrate different solutions with each other. And as you saw in the video also, for example, the station manages the payload box also and the chain of custody. So we have a manifest system that allows to track the payload box, for example, from A to B, from the end to end essentially, and really also allow the hospital sometimes new ways to track their logistics, because we would be surprised sometimes how rudimentary some of these logistic solutions are still today. And this new way of tracking things and then sending and receiving goods also enables the different companies or hospitals to start track things differently.
That actually leads very much to my next question, which was going to be, I mean, you mentioned it as a out-the-box solution, but maybe interested to hear from Klaus and yourself. I mean, maybe Klaus first. In terms of integrating this new technology into your existing systems, how did it go in terms of training? And then maybe for Alex, like in terms of the size of the team who need to come and set up these networks, what's the situation there?
Thank you. So I think the most important part is always to involve the personnel, the public, everyone that could be somehow affected by the solution as early as possible. To really explain why do we do that, what's the reason behind it, and also to try to get them in touch, maybe literally or as close as possible, to really be able to ask questions and to experience those new solutions. So that's what we started first. We said, okay, there's something coming up. We want to start such a project with Matternet. It's about drones and explain the use case. And then it's also for the lab personnel itself that would have kind of direct interaction with that they say, okay, how do we actually want to approach that? What will be the main topics we have to address? How is as you said, the integration in the normal process? And what we try to achieve is that, I would say maybe in the end, the lab personnel, for example, doesn't even have to know or have to get any access or direct connection to the drone, just saying, I want the fastest possible logistics solution for that sample. and that's why I use the process A, and I know then it will be delivered currently then with the drone. And to keep all the rest of the processes untouched if possible.
Yeah, and from our side, I mean, this is a real aviation operation, so we have to have very strict training programs and also get that approved. So in Switzerland, we have worked with the Federal Aviation Authority of Switzerland to really get to a training program that's also accepted by the authorities. And essentially that's focusing on training our pilots. In this particular case, that would be what we call the flight director that is sitting in front of mission control, as well as our technicians or maintainers that we train also according to already existing guidelines or regulations that are out there for maintaining aircraft. And yeah, so they need to follow this program and have a certification from us to be able to handle our drones.
Maybe a bit more specifically though, for example, in Berlin right now, how big is the Matternet team? I mean, is it, you have people there sort of permanently monitoring and managing the operations, or is the plan to sort of hand it over to someone more local or a local partner?
So the target is always to have an operations team on site that is trained and able to do that. And also due to regulations, we can't hand that over to the customer necessarily. UPS is a little bit of a special case because they are an airline essentially. But usually we would set up an arm of our airline in this region and would then run the operation.
Okay. Again, maybe linked to this, maybe this is a bit of a harsh question, but what about the debate between, automation taking away jobs versus giving jobs? I mean, how many careers sitting in Berlin right now not able to deliver because Matternet are delivering on their behalf?
At least from a technology provider view, I think there will be a lot of new jobs that we cannot even imagine right now. But let's look at the station, for example. I mean, the station needs maintenance and maybe other services to it that will create a complete new field of jobs, essentially.
And maybe also from our side, I think you can't stop innovation. I think that's the first part. And I think there is always, with innovation, there are also new opportunities and new jobs or new profiles that are needed. And we as Labor Berlin, we always see, we always search, as said, for possibilities to improve patient care. When we look at the analytic instruments, for example, there is so much progress been happening in the past 10 to 20 years, and when you now want to reduce the analytical time from 5 minutes to 4 minutes, it's like a huge investment or a huge technology project that it's hard to achieve. But where we really can save a lot of time, that's the transport itself. There we really lose time, and that's where innovation can really happen, and that's also that we focus on that, even though it's not our usual topics that we work on. There we see we can really improve patient care, and we don't see that as a risk, but as an opportunity, definitely.
Okay, are there any other questions from the audience? No? Oh, yeah, a comment?
Sorry, I can't stop. It's too good of a topic. So, but I think it's important, the question you ask about the fear of losing work. And what we've seen during some similar operation in Sub-Saharan Africa is that it's actually creating more jobs because your system is becoming more efficient. So in this case, I can imagine in the lab they are actually doing more testing, more of the work that they're, right now the bottleneck is a time of sample transport. You optimize that by an introduction of drone, it's more efficient, you have more time to actually do more testing, more treatment, and so on. It's like a chain effect. So that's what we've seen, and that's probably what similarly is going to happen.
Any comments on that?
Yeah, I think I can really emphasize on that because currently you always have to calculate the transportation time, and of course if that is totally different, like a tenth of the time than before, it may be that the whole process has to be redone because you say, okay, actually we can do it more efficient if we, if we readjust the whole process. And then you also have time for other topics that really can make a difference. So as Oliver said, I think there are also opportunities that we don't see yet, and we see it when we have it implemented, and then we will see next generations of possible changes.
Great, and maybe just a couple of last questions then. So. Obviously, today we've seen a short demonstration. You're flying regularly as Matternet over a number of locations, but what could be done to maybe speed up the uptake, or what would you like to see in, I guess, maybe from the aviation authorities or business or funders? Like, what are the key things maybe holding back drone deployment?
Yeah, so I mean, one of the I guess, biggest factors here is regulatory. And we see this across the world right now. People are trying to figure out how can we implement drones safely into the airspace. And it's a hard problem, but at the same time, I think we just also need to listen a little bit more to industry and the solutions that are already existing. And I think working off of that sets us, or would set us up for a good start, at least. And then also, at some point, it's also important that just we need to have rules in place and work off of that, and maybe also accept that these rules are not complete, and that we need to have processes that allow certain carve-outs, essentially, to do stuff that is not so common. And there was a group called JARUS, the Joint Authority of Rulemaking for Unmanned System, that was working on such an approach. And it was partially adopted by EASA, but taken into a direction maybe where it actually defeated its original purpose. Because it's important that we in German, we would say to leave the church in the village, right? So if it's a high-risk operation, obviously we need to make sure that we mitigate that risk. But if it is just flying at a demo area or somewhere in a controlled area, you need less mitigation. So I think this concept is really important, especially as drones are very versatile and can do a lot of things. And also there's a lot of different drone versions, and so this allows us to be very, or to address all these different needs in different ways, and therefore the regulation needs to be built in a way that allows that and not prohibits everything. I think that's the important thing.
Okay, and actually my final question, which seems quite pertinent now, is I'm wondering where you stand on the debate between sort of the airline industry regulation versus the sort of drone unmanned regulation. I mean, just briefly, the debate kind of goes, okay, the airline industry has been incredibly successful in instilling amazing safety standards over the last 60 years. Everything is monitored to the final point. And then you've got all the drone startups who are coming here like a little bit faster, a bit frustrated by all these rules and regulations. Is there a balance to be found in there, or should it go one way or the other?
Yeah, I think this is a very important thing, or a very important balance that needs to be struck here, because what we see definitely also is that a lot of drone companies that are starting up right now are coming from a hobby space, which is good to develop new technology, but I think especially when we operate professionally over a city or in a commercial setting, I think it's very important that we bring this expertise and also learnings from the aviation side into this unmanned world. And I completely think that it should be more dealt with like in aviation already successfully done so. But at the same time, again, we need to recognize that we're not operating a 737 with 200 people, and also that not all aircraft look the same like they do right now, right? I mean, 737 from Boeing looks almost the same like A320 from Airbus here. So obviously it's easier under quotes here, but to build regulation and specifications also for these type of operations and aircraft, rather than what we have in the unmanned world, where you see everything essentially. And also the missions are so versatile, so different. Everything from inspecting a bridge to transporting medical samples. So it's very different.
Great. All right then, I think we're almost out of time, so we'll wrap this up. We'll say thank you to everyone who's attended here in person and everyone who's watching on the live stream and at the ITS Congress. In half an hour, we have a demonstration from Blue Atlas Robotics, and then later in the day, a demonstration from Volocopter. So we look forward to welcoming you to those later on. Thanks very much, Klaus and Alex, and we'll wrap it up. Thank you.
Thank you.